Thanks for inviting me here today. I'm Sara Falsini from the Department of Biology of the University of Florence. And I would like to talk about municipal waste and in particular about plastic waste, focusing on their ecological risk. Everybody, humans in general, every day produce waste. Which says a lot about our habits. If we are adults or children, if we live in a country with high or low and medium per capita income. For example, in Italy, we produce every day 1.3 kilos of waste per capita. And this number varies within European Union and increase overseas, for example, in Australia or in North America, and decreases in South Asia or Africa. In particular, if we were an inhabitant of South Asia or South Africa, we would produce approximately 0.5 kilos of waste per day per capita. If we live in North America, we would be the world's largest producer of waste with approximately 5 kilos of municipal waste per day per capita. Next slide. So in this context, among the municipal waste, plastic waste are the most insidious. And especially because the plastic polymer are used in a wide variety of applications and have become essential in our daily life. In the last 30 years, plastic polymer has constantly increased. The production of plastic polymer has constantly increased. In 2018, over 360 million tons of plastic are produced worldwide and 62 million tons in Europe. The most produced polymer in Europe are polypropylene, polyethylene, polyvinyl chloride, showing similar properties to polyethylene, but polypropylene is slightly harder and more heat resistant. The major product of degradation are formaldehyde and formic acid. Polyvinyl chloride is a non-aromatic polymer which contains CCl bonds, which are susceptible of homolytic cleavage and radical decomposition pathway. Polyethylene terephthalate is characterized by an aromatic group and two carboxyl groups, and the degradation of this polymer led to an increase of hydroxyl end groups. Polyurethane is composed by an organic unit that are linked by carbamate, and the major product of decomposition are hydrocarbons, aldehydes, alcohol, and organic acids. Next slide. Due to inappropriate waste management, plastic waste are dumped into the environment, where they undergo wear and tear, such as mechanical degradation and slow photothermal fragmentation. And these processes can deteriorate material integrity, leading to small pieces in the order of less than 5 millimeters that are known as macroplastics, also known as primary microplastics, secondary microplastics, sorry. And because the microplastic of this dimension are also intentionally produced by are also intentionally produced to be used in cosmetic products, such as exfoliant or toothpaste, or by industry, such as Bioplastic, and in this case are called primary microplastics. These microplastic can undergo to further biodegradation, which to reaching the dimension less than 100 nanometer, and in this case we talk about nanoplastic. Okay, next slide. And the problem is that when microplastic and nanoplastic are released in the aquatic environment, they can concentrate chemicals. They can concentrate such as metals or other chemicals, and they at the same time, once microplastic has been degraded enough, they release in the environment additives that can be bioaccumulated by organisms, and also they can be itself bioaccumulated by organisms, and the bioaccumulation potential depend on the dimension, increase with the decrease of size. So the problem is that when the aquatic organism ingest this microplastic, they can enter through the food chain and they can be eaten by other organisms, such as humans or terrestrial organisms. So the problem is very tricky. Go the next. And microplastic and the ecological risk of microplastic is based also on the ability of air to transport microplastic to new areas, contaminating them by reconcentrating. Therefore, there could be aquatic and terrestrial environment could be polluted by microplastic, airborne microplastic. There could be a dynamic interaction between microplastic from different media, soil and water, becoming airborne and contaminating air, while airborne microplastic may deposit on soil and water. This is the process that you can see here in this picture. The next. And the problem is that in 2017, China announced an unprecedented ban on its import of most plastic waste from foreign countries. So China banned the import of our plastic waste, and so we have to do something. We have to do now, because otherwise we have to manage 110 million tons of plastic waste by in addition then the normal plastic waste that we produce by 2030. Okay, so in this situation, European Union released a circular economy package with legislative proposal to reduce to increase the recycling of plastic packaging, for example, which represent 30% of plastic in general, plastic packaging is the 30% of the plastic that are produced, and this package regard also municipal waste and food waste, and also some special waste like construction of the waste belonging from the construction and demolition sector. So the next slide. And the last year is is an important here because for the first time, European Union banned the single-use plastic like plastic plates, cutlery, straw, balloon sticks, and cotton buds. So in this situation, European Union reacts to the situation, and the next slide, and bioplastic could be a valuable alternative. Now we produce 2 million tons of bioplastic, which is a small part of the plastic that are produced worldwide. And maybe in some sector, as we told, as we say previously, could be necessary in could be needed in some sector like biomedical sector. So I just raised the question for the pub. And so thank you. The next. And just I am proud to show you our book. It's just in Italian, but anyway, it's a good result for us. It's a result of an European project, Inspires, which is led by Giovanna Pacini and Franco Bagnoli. And the other co-author is Federica Ruggero, which I would like to thank for his important contribution. And thanks to all of us for the attention.